All right, welcome everyone. This is our reference table brain dump. These are the notes that I want you to make on the reference table at the very beginning of the Regents chemistry exam. Credit goes to chemistry teacher Prin First, who teaches in Auburn. I got this idea from her. I've adapted it a little bit. It's mostly hers. And big point though, these notes that you're going to make on the reference table, you cannot make them until the test actually begins. So you can't make them early, you can't make them in advance, that you have to wait until they say you may begin the test. Then I want you to take the first 5 to 10 minutes of the test and make these notes because they're going to help you throughout the exam. So first up, you need your white reference table, obviously, and making the notes in something other than black would probably be helpful. So if you have like a colored pencil or a marker, it might be good to make the notes in that. First up, table A. I want you to circle the S, the T, and the P for STP, standard temperature and pressure, remembering that we have these values, they're numbers, and they're given to us on table A. Next up, table B, heat of fusion. You're going to write next to that HF because that's what it is. That's that heat constant in our heat equations. Heat of vaporization, you're going to write HV, and specific heat capacity, you're going to write C. So you're going to label them with the one-letter designations so that you hopefully remember that, okay, when we get to that point, that's what we're going to do. Now, next page, table E. You're going to make a couple notes on table E. First up, you're going to find next to the hydronium, you're going to label it acid, and next to the hydroxide, you're going to label that base so that we know our acid and our base. Next up, for table E, you are also going to say, if it's 3, sorry, my smartboard's having a moment. All right, you're going to say if it's 3, table E. This goes for nomenclature. Remember, if there are 3 elements in your compound and you have a metal and a nonmetal, then and 2 nonmetals, then you're going to go to table E for half the name. You're also going to write ionic plus covalent, and that means that with these polyatomic ions that are in table E, any compound that contains one of these polyatomic ions and something else will have both ionic and covalent bonding in it. Next up, table F. These are our solubility guidelines. You're going to draw a rectangle around the middle 2 columns, and across them you're going to write insoluble. Because remember, this is kind of like our funnel where everything in the middle is insoluble, and the soluble compounds are the ones that are on the sides. Next up, table G. What are you going to do on table G? You're going to circle the per 100 grams of water as a reminder that this is for 100 grams of water. If we had 200 grams of water, we'd be doubling all the numbers. And then you're going to write next to it, you're going to write gases go down. So all the lines that go down, like NH3 and SO2, those are gases. They become less soluble in water as the temperature increases. Then on table H, what are we going to do on table H? We're going to label the dotted line as STP. It's standard pressure, 101.3 kilopascals. And then you're going to draw a big arrow underneath it from left to right like that. And on this arrow, you're going to write increasing boiling point, meaning that from left to right, ethanoic acid would have the highest boiling point and propanone would have the lowest boiling point, and that we increase in boiling point from left to right for these 4 compounds. And you're also going to write increasing IMFs. That our IMFs get stronger as we go from left to right. Then table I. All right, so table I is all these different heats of reaction. And what I want you to do is circle this 101.3 kPa and 298 Kelvin. There were some questions like this in the sample exam we did in class, or you did as homework, that you have to figure out the delta H, you have to figure out the kilojoules for these reactions. And the clue that's going to be in the question every single time that'll be to go to table I is it'll say, you know, what is the enthalpy of reaction at 101.3 kPa and 298 Kelvin for the following equation. They will say that. They will give you those numbers, 101.3 kPa, 298 Kelvin. That's kind of the cue that you got to look up that reaction in table I. Then you're going to circle this thing on the bottom here, which is not really legible on my screen, but will be legible in your reference table, that says a minus sign indicates an exothermic reaction. So we remember this plus, this minus, exothermic reaction. Now, table J, we're going to make a number of notes on table J. First, we're going to write at the top of the metals most easily oxidized, because the metals at the top are more easily oxidized than the metals at the bottom. And then you're going to write A before C, and that stands for anode before cathode. Anode is where oxidation occurs, cathode is where reduction occurs. And we can use table J to work out if you have two metals, which one is the anode, which one is the cathode. The anode will be higher up on table J because it's going to be oxidized. The cathode will be lower down on table J because it's going to be reduced. So A before C. We're also going to write, I'm going to do this to the right. I want you to do it underneath your table J. We're going to make a little number line. So we're going to do -2, -1, 0, +1, +2. A number line, and if we are increasing, remember for increasing in charge, you're going to write LEO, loss of electrons, oxidation. So an increase in charge is oxidation, and then we're going to draw another arrow going in the opposite direction. Now we're decreasing in charge, and we're going to write GER. Leo says GER, gain of electrons, reduction. I also want you to make a note here, the voltaic cell song. If you want to write the lyrics, we start at the anode, electrons are lost there, etc., etc. But like a note there to remember our song. Next up, next page, table K, common acids. I want you to circle, sorry, smartboard again, having a bit of a moment, but you're going to circle the word acid. Circle the word acid, then you're going to write next to it the Bronsted-Lowry definition of acid, which is donates H+. And bases, you're going to circle the word base, and next to that you're going to write the Bronsted-Lowry definition, which is accept H+. So we're going to add that in. Then you have this little space right here that's on the bottom. We're going to make a little rectangle like this. You're going to draw a line through it, and then you're going to say H3O plus on the left and OH minus on the right. And what you're going to do is write in pH values. So 0 all the way on the left, 14 all the way on the right, and then 7 smack dab in the middle. And acid is from 0 to 7, and that means there's more, it's sort of like you take a chunk out of this, more hydroxide than hydronium. I'm sorry, more hydronium than hydroxide. Base is between 7 and 14. That would be more hydroxide than hydronium. 7 is right in the middle, equal amounts of hydroxide and hydronium. Not none of either, but equal amounts. For table N, we're going to circle decay mode. And next to that, you're going to write natural, indicating that on table N, all of these are natural transmutations. They're not artificial transmutations. These are the natural decay modes for all of the different radioisotopes. For table O, next to table O, we're going to do the sign to say what table O means. So we're going to write an X, and then we're going to write mass on the top left and charge on the bottom left so that we know what table O is saying. And then for the first 3, alpha, beta, gamma, which are really the big 3, alpha, beta, gamma, we're going to kind of draw an arrow like this, and it's going to say stronger. Stronger. So saying that alpha is weakest, the beta is in the middle, and then gamma is the strongest type of radiation. Table P, organic prefixes. We're going to write in our covalent prefixes to the right of it. And the covalent prefixes are the same from 5 to 10, but for 1 to 4 they're different. So we're going to write mono, di, tri, tetra, mono, di, tri, tetra, next to 1, 2, 3, 4, so that we know when we're doing covalent nomenclature that we have those prefixes there. Table Q, we're going to circle the term homologous series with alkane, alkene, alkyne. So again, saying that if it asks for what the homologous series is, we know we're going with either alkane, alkene, or alkyne. Then we're going to circle the suffix ane, and we're going to point to the single bond. We're going to circle the suffix ene in ethene and point to the double bond. And then we're going to circle the ine, and we're going to point to the triple bond so that we know that ane means single, ene means double, ine means triple. And then we're going to write saturated next to the alkanes, unsaturated next to the alkenes, and unsaturated next to the alkynes. Table R, we're going to circle the most useful column, which is the last one, because it gives us all these lovely examples that we can try to sort of figure out and base off of on our and work out what they mean. Periodic table, we're going to do a number of things on the periodic table. First of all, we are going to point to group 1 and 2 and say very reactive, because they only have a few valence electrons. They're highly reactive. We're going to point to the noble gases, and we're going to say don't react, because they don't, because they're stable. because they have a full valence shell. They have an octet. We're going to make a note of our diatomics, diatomic elements, which is H NOF down, but I'm going to add in the 2, so that means hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They're all diatomic, so they always are found together in nature. We're going to write in anywhere, realistically, we're going to write in don't guess table S. So if there's a question about atomic radius, about electronegativity, about ionization energy, I don't want you to guess at the trend because you might guess wrong. Atomic radius actually decreases left to right. But if you look this stuff up in table S, you'll get it right every time. And then we also need to add in our acronyms. We have a whole bunch of acronyms that we learned this year, and the periodic table is a good place to do it. So we're going to write in BARF, which means it's for bonds. If you break bonds, you absorb energy. Break, absorb. If you release energy, that means you're forming bonds. So break bonds, absorb energy, release, form bonds. Then we're going to write in SNAP, which has to do with polarity. So symmetrical distribution of charge is nonpolar. Asymmetrical distribution of charge is polar. And then we're going to write in plight. So this is for ideal gas behavior when our gas is most ideal. Pressure low, ideal gas, high temperature. So our periodic table is a good place to do that. Then on table S, the only note that I want you to make is for the melting point, boiling point, it's for phases of matter. So I want you to write an S to the left of melting point. I want you to write an L in between melting point and boiling point, and then a G after boiling point. So that means that if we're at a temperature that's in, if the melting point, let's say is, if we take, hydrogen, it melts at 14 Kelvin and it boils at 20 Kelvin. So if we were at, let's see, 15 Kelvin because it's in between melting and boiling, then hydrogen would be a liquid. And then the very last page of the reference table, all our calculations, we're just going to make a note on a few of them. Combined gas law, temperature has to be in Kelvin, so we're going to make a note there. For titration, we're going to add in number of H's times MAVEA equals number of OH's times MBVB. Heat, we're going to write table B right next to, in the same box where it says heat, as a reminder that we have those constants there. Q equals MC delta T, change in temp. So if you're changing temperature in the problem, we're going to use that one. For Q equals MHF, we're going to write melt. And for Q equals MHV, we're going to write boil. And then the final thing we're going to write, I want you to do it underneath table, the table, but I don't have space there, so I'm going to write it over here. Average atomic mass is mass times percent over 100 plus another one, mass times percent over 100 for isotopes. So these are the notes that I want you to make on the reference table. Now, we're going to practice this a lot in class, and my philosophy is always, if you don't remember all of them, well, that's okay, but the key is that you remember most of them, because if you remember most of them and you get them down, it will help you on the exam. And I have had several students in the past where I know for a fact that this reference table brain dump has been the difference for them between passing and failing the Regents exam or getting mastery and not getting mastery. So this is definitely something that has been proven to help students perform better on the Regents Chem test.